Hello guys, and today we'll be going over ANSYS tutorial 1 for MEC 448 design of energy systems. So our task for today is modeling a 2D pipe of a diameter 7 centimeter. This is our inlet, and length of 100 centimeters, which is connected to another pipe of 6 centimeter diameter and 30 centimeter length, which is perpendicular to the first pipe at 30 centimeters from the inlet. Water enters from the left, so you can see the diagram from the left at a 30 degrees angle, and water in the small pipe enters at 1 kg at 80 degrees C. The task that we are told to ask is, calculate the final temperature of water coming out of the right side of the longer pipe. So over here, assume atmospheric pressure at the exit, verify the problem using calculation, plot the temperature profile, pressure contours, and velocity vectors inside the pipe. This is the example that was provided for us. So, how do we get started on our own laptop with this ANSYS setup? So, you can install this software from Student Edition. Go to this website, www.ansys.com/academic students and ANSYS, and then we can click on download ANSYS Student 2025. So if I go on this, we have it. We click on it, and what happens is this will save the zip file. Now mine is already saved, so I don't need to save it again. So I'll go back. So this is already saved for me. Now what you need to do is you need to extract this file. So if you go back, so you'll have this file. You can extract this file, and then you'll have the file over here. You double click it, click on setup, and go on setup, and then from there you just run the setup, agree the terms, then click next. So it'll just open up. I'll show you. So it does take a while to start off the setup, but once it does, all we have to do is just press two buttons. So you can see here, just press agree, click next. You can save it wherever you want to save it. Mine is just by default. If you press next, it'll start installing it. So you can see start installing. Mine is already installed, so I'm going to exit the installation. This will take some time, so 15-20 minutes. And let's go back to the software. So the way we want to start is we click on Workbench. So we go Windows, Workbench 2025. It will take some time to load. Once it's loaded, we can get started. So a couple of things to note when we do start the software is some of my settings, you'll see that it's already been changed, but you might not see the same interface. So the way we change it is I will show in a minute once this loads up. Alright, I think now it should be loading up. Here we go. Now you'll notice this property tab on the right is normally not there. So the way we view it is we go to view and we check the properties to see these properties, the properties table. And this is important for our things later on. So there are lots of different components that we care about, but for us we have flow and flow. Now you can either drag this like this, or you can double click this. So both are fine. All right, I'm going to just delete this, and then it's fine. All right, so click on geometry, and because the properties are there, we need to change it to 2D. So you can see this, we change it to 2D. Once 2D is done, we right click our space, and we're gonna go to new design modeler geometry. Okay, now it's important to note that this might take some time. It will say starting design modeler, so that's fine. Now if your setup does not say ready on the bottom left, then this will not work on your system. There's an issue with the licensing, or there's some issue with the software. You need to reinstall it. Now this happened with me, so just be careful. If it doesn't say ready, then you cannot begin. Okay, so let's click on XY plane, and we click on right click and look at this is perpendicular. Now you might not see this grid, right? And the way we show it is, before we do anything, let's first change the units. So we are doing units in centimeters. If you noticed our example here, it's mostly in centimeters, 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 centimeters. So why not just stick to centimeters? Okay, so the way we see this grid is we go to tools, go to options, go to sketching, and these two drop down menus you click to yes. So we want the grid in 2D, yes, and we want to snap to grid 2D, and we press OK, and we're going to get this grid now. Okay, so we want to draw a basically what we want to draw two rectangles. So we want to draw rectangles that are on the center line or centered, and then we want to draw this extended T shape here. Now there are two methods. I'm going to go over the very basic method, as in we'll be drawing line by line. This will take some time, or you can go ahead and be advanced, or you can just, what you can do is you can draw two rectangles, you can generate them, and then from there you can trim them. That's fine as well. There's nothing wrong with that. Okay, it's just for me, just so that everyone can look at it and they can do it however they want. I'm going to just stick to lines and just modeling them via lines. That's it. Okay, so let's go back to our modeler and let's see if we can draw some lines that we care about. Okay, so we're already centered, so we are modeling, we click on sketching, and we are in the sketching toolbox. So from there, I'm going to draw a line from here. So I'll start from the center, and I'm going to draw a horizontal line to the left, and this was going to be 30 centimeters, right? So the way we modify the dimensions is we go dimensions, and we click on this general. You'll see it's already clicked, so click on general, and you see over H1 is 28 centimeters. So we want 30, so we press 30 and we press enter. So now it's 30 centimeters. Now you notice that the diameter for this side here should be 7. So what we can do is 3.5 above and 3.5 below, right? So from this point here, what we can do is, if for example, let me get this line draw again. So line from here, let's just extend it, and from here, let's just extend it. Okay, now same thing again. We're just going to take the length, and you can see this is 5. We want 3.5, so 3.5, press enter, and the same thing here, 3.5 and enter. So 3.5, 3.5 and enter. Now that that's done, what we can do now is we can now draw horizontal lines from this. So let's draw a line again, and from this point here you can zoom in and you can you can pan using this icon here. There's a pan icon. You can pan and zoom in and pan. So we just want a horizontal line. So from here you'll see that it's not horizontal, right? And you can try your best to make it horizontal. It's very difficult. So what we can do is we can have another supporting line that we can have, right? And sometimes, let's say you've rotated it easily. Go to modeling, right click, and go look at it again, and you're back to normal. Now, as I was saying, let's go back to the line function here and start from the center line, center point, and we're just going to do the same thing again. We're going to go to dimensions, and we're just going to take the dimensions of this, and again we're going to do 3.5, and let's do another line. Let's draw here another line downwards, so 3.5. Okay, and let's also take the dimensions of this. So from here, v5, and that should be 3.5. Okay, now let's draw the line that we said we wanted to draw from this point here to this point here. And similarly, we're going to draw this line from here to here. Now, we're going to change the dimension of this, right? We're going to go here. That's fine. We're going to go here, where is it gone? H6. And we're going to change this to 100. That's fine. Let's first get rid of the other ones. So let's delete this, and let's take this. Let's take another dimension. So dimension H7, and let's make this 100. Oh, goes the wrong way. So let's go back here. Perhaps we can extend this line, or maybe let's, for now, let's see if we can. Okay. All right, that's fine. Okay, so we just take this line over here, and perhaps we can just change this to 100, maybe. Then it's gonna go this way, so perhaps we can just draw another line here, or the center line here. We can draw, so from this line forward, we can go to, let's define this line as well, dimensions, and let's define this line here. And this line is H8, so H8, and let's define this by 70. So 70. Sometimes you want to zoom to fit, so there's an option over here, box zoom, zoom to fit, which is F7. You can do that. Now it's zoom to fit. Now again, all I'm going to do now is draw a line from here to here, and from here to here. Similarly, we're just going to pan all the way here, and again we're just going to take the dimensions. So this dimension here should be V9, and that should be 3.5. And same thing here, this should be, again, this should be V10, 3.5. Okay, so this line here, what we can do, yeah, that's fine. Let's get rid of this here. Press escape. So press escape, and you can delete this, and you can delete this. Now, I'm going to pan here, zoom out. And now what we can do is, instead of this line we have here, so instead of this line, so what we can do now is, we can delete this line, and we can delete this line. We can make a normal horizontal line that goes from point to point. So from this point to this point here, and from this point to this point here. Okay, and it's okay. All right. Okay. So now we can double check our dimensions by just doing this. So defining this H12, and that is 100, and that's what we care about. Okay. So let's go back to the draw function, and let's get rid of these helpful lines that we came across that we don't need anymore. So let's get rid of this. Let's get rid of this. Now, notice that we only have one box right now. And let's get rid of this line as well. Let's get rid of this. Let's get rid of this. So now we have a normal rectangle box, which we could have drawn earlier. Now the way we see it in ANSYS is we have to first generate it. So if we click this icon, this lightning icon, this should now have generated this particular shape. Now we can make a box directly from this by going to surfaces, and then when you go here, not selected, click on sketch 1, and then we can go to add a material frozen, go select again, click on sketch, apply, and then we can create it. So now this is a box. Okay, this is a box that's generated. Now from this box, what do we need? We need another 30 centimeter box, a 30 centimeter rectangle going downwards from here. Now what we can do here is we can now, for example, let me just pan. Okay, so let's go back to our shape. Normally it's better to do it in the same sketch, but you can do it this method as well. So what I'm going to do is I'm going to do Control Z again. I'm going to get rid of this surface. So delete, yes, and I'm going to go back to the sketch. So sketch, I'm going to go back to the sketch. Now I want a diameter of 6, so from each side that's 3. So now I'm just going to go here, I'm going to go here, and then let's see if we can do the dimensions. So dimensions, let's look at here, and this should be H12, H14 should be 3. So 3 there, and also 3 here. So H14 should be 3. So this is 3. Now all we need now is what? We just need a line downwards of 30 plus this diameter here, the radius here, so which is 3.5. So another straight line downwards, So we can, it doesn't matter if the length, just as long as it's down, that's all that matters. Okay, so now dimensions, general, and v15, we do this to 30, now plus 3.5, that's 33.5, so 33.5, 33.5, same thing here. And we're gonna do v16 over here, we're gonna do 33.5. Press OK. Now you can pan downward, and now we can join these two lines. So let's join this point and this point here, and that should be done. Okay, so now what we need is press escape. Now we can get rid of this, and we can get rid of this. Now let me zoom, pan up again. Now what we can do is, before we generate this, let's trim the things that we have, when we can do that by the modify. Go to the trim option, let's zoom in a bit, and let's get rid of this, and this. These are straight intersecting, so we can get rid of this. And what we can do now is we can fillet these two edges together. So the way we do this is we get two edges, 1 and 2, and it does the edge fillet for us. Now we can take two other edges, and they've done the same thing. Apologies. Now we have everything we need. Now we can get started. So let me also let me get rid of these. Okay, so now let's do what we did earlier, is do the surfaces from the sketch. We go over here, and then we apply material as frozen, select the whole sketch now, and press apply, and then generate. Now we have the whole thing that we wanted, correct? Now we are done almost with everything to do with the geometry. We're going to come back to the geometry afterwards, but for this time being we are done with the geometry. So now what we can do is we can say we are done. Let's close this menu. We'll come back to it later, when we will have to come back to it later, but for this time being we are done. So now we're done. Let's close this. When we close this, let's go back to our project schematic. You'll see there is a tick mark. Now what's the next step? The next step now is we go to the mesh. So we double click the mesh. It'll take some time, and then it will load up. So then it will load up. So it does take time. It does take a bit of time. Okay, so you can see now that there is something that's loading up. So take some time. Okay. Alright, so now we're done with this green check mark. Now we can start by right clicking on the mesh. So let's right click on this mesh. Right click on this mesh. And we care about what? We care about these two fillet edges, right? We care about this. So what we're going to do here is we're going to do a insert, and we're going to now click on, before we do anything, let's think about what's already given to us. So when you click on the mesh, we have a couple of items here. If I can zoom in here, let's take a look at this. So we have display, default, and we have a couple of other things. What we care about is our sizing and quality. Let's see if we can change this. Now the sizing, we can't really change much. There's nothing much to change for us, but the quality is what we're concerned with. So the qualities, we want the smoothing to be very high, so we can click this to high. Okay, so that's the quality part done. Now next, what we can do now is we can just generate. So now let's see what this looks like. So if we generate this, so this is generating. So this is what it looks like. Right, this isn't very fine, but it is a mesh, right? How can we make this more fine? What are some of the things that we can do? So what we can do now is we can do right click on the mesh again. So right click on the mesh, insert, and we can look at, for example, over here, sizing. Alright, now what do we care about? Let's look at this geometry. We care about these two edges. 1, We control click this and we control click this. These two we're control clicking, and the element size we want to be what? We can save element size, and we want this to be 0.001 and press enter, and no selection. We'll try again. So this, we want to do what to it? We want to apply selection, and this also we want to add to the selection. Now that's done. Let's generate. So this is now generated. Now you might not see it. You have to see it after you go to the mesh. Now you see there's very fine now along these edges, right? Okay. What if I wanted the edges to be very fine, or I want it to be fine all across this mesh? What can I do? Now, what you can do is you can click this refinement icon, and then when you click on this whole thing, this whole surface, and click on apply. Now, we can click on refinement and we can increase the number of refinement. Let's go to 3. Now notice when we click on generate, it's going to do its thing, and it's ready. Now look, it's now very fine across this, and the whole thing has a lot of more standardized meshing, which is what we want. So that's pretty good for us, right? That's pretty good for us. Okay, so now in that sense we are good to go for the next section. All right, so now we've done everything. Now let's close this. Let's close this this mesh menu. So we've done all the meshing. Now let's close this. All right, if you see that it's not fully done, let's do update. We click on the update. It should be done. Let's check. You should see a green tick after it has been updated. If not, then we can go back to it and see what's the issue. So it might take some time. And now let's go back to what other we were saying. We were talking about how we'll have to go back to the geometry that I was talking about. Now, why did I say that? Why did I say, oh, we have to go back to the geometry at some point? Well, we'll start the setup and we'll see what we need. So double click the setup and it's going to start. Now we care about 2D, and click on double precision and we can start. Okay, so it's getting started. Okay, so whilst it's starting, I will go back to the other things that I was talking about. Okay, so you see there's a lot of stuff going on here. Just press OK and you're fine. Okay, let's press OK. Now these things, they already done for you. This pressure based, this is steady system, absolute velocity, and it's a planar system. Alright, that's good for us. Next, let's look at the units. So the units we have for length for now is usually your SI units, so we can just default to SI and press close. Sometimes you can change to centimeters, but that's fine. Now let's look at our general setup. This is our general setup menu. Now let's go to the models. What models are we concerned with? And so double click it. The ones we are concerned with is the energy, so we can input the energy equation and press OK. And then we care about the viscous SST. Now with this, we care about the K epsilon and the realizable, and that's it. Okay, so that's the wall function that we care about, and that's the realizable. Press OK, and that should be good to go. Okay, now, so we're done with the model section. Let's close this menu so we don't get confused with what's going on. Now let's look at the materials we have, and especially the fluid we care about. So let's click on fluids. So let me see if I can task page. Let's open the task page again. So now this fluid part we care about is we want to add more fluid. So if we look at this fluid, we have air. Now we are looking, if you remember what the question was asking, the task was for what? Water, right? Water. So we need to add water to the database. And how can we add them? We have to go to the Fluent database. So click on Fluent database. Now we're looking for water liquid, so you can go all the way down, and that is water liquid. Double click this, and then it should be copy. Maybe it'll, okay, close and close. Now if I remember correctly, this should show up in our fluid. Now let me open the task window again. Where is this task window? Display mesh. Let's see if we can find this interface again. Where is it gone? Trying to remember outline view. Yeah, task page. Here we go. Okay. Now we are looking at, let's say, for example, boundary condition. Here we go. Let's go back to materials. Double click materials. Okay. So air. Let's click on create edit. Let's change it to Fluent database. Liquid. We care about this. It's not selecting the water. So let's see if we can try again. Okay, no. Fluent database. What does it say here? Select all shown, deselect all water liquid, and then we want to copy selection. Copy. Yeah, there we go. You can see now it's showing up there. Press close, and now you have it there. So press close again, and we care about using water liquid. So press close, and that's good to go. Now, I mentioned why we'll have to go back to the geometry is because if you look at the boundary conditions, the Fluent system itself, if we double click this, is not recognizing the inlet or the outlet or another inlet or the wall because we didn't define it when we were in our geometry. So what we're going to do now is we're going to go back to the interface of the project schematic. We're going to double click the geometry, and we're going to click in edit geometry in DesignModeler. Now what we're going to now define is our inlet, our V1, our V2, our outlet, our symmetry, and our walls. Okay, let's go to XY plane again. Click on look at. Now, what we're going to do now is click on this. This is where it says Control E or just edges. So you can click on this, and I'm going to drag my mouse, and I'm going to rotate it as much as I can. Now this is my V inlet, right? So we're going to click this edge. We're going to click this and this. This is my what? This is my the two things that I care about. Now we're going to click on this called name selection. So name selection, we're going to call this what? We're going to call this our inlet main. So our inlet main. Okay, done. So now whenever I click this, it knows that it's inlet main. Now similarly, we're going to do the same thing for the secondary inlet. So let's go here, from clicking the same thing again and clicking this whole thing. So now this is our concept for here. Where is it gone? Oh, press exit. Okay, now try again. Generate should be fine. Click on this, go to tools, name selection, and again now this is our inlet secondary. Press OK. This is now our inlet secondary. So whenever, if you look now, if I click on inlet main, it highlights in green that this is the inlet main. Inlet secondary, this is inlet secondary. Okay, now what do? We need our outlet as well. Now what's our outlet? So what are we thinking? Where our outlet is going to be the other side, right? So we're going to have the outlet, so the right edge. So now if you're ever confused, you just go back here, look at, and then you can just zoom in, and then you can either drag this ball here like this, so now it's very easy, or you can use the pan and just move it to your liking. Okay, click on the edges again, and we're clicking on this, and then control on this as well. Obviously I could have made this one line from the beginning, changed it, but it's the same thing. Okay, now we're going to go to tools, and you can see it's not loading up, right? Why? You see this icon here, it hasn't generated it, so you have to generate it first. Now all of them are ticked. Now what you can do is click on this again, control click this, and then tools again, and name selection. So this selection now is what? Our outlet. Press OK. Again, see this icon, we can now press generate. Now it's generated. Now we can look at what else are we done. Now we have the center line, the horizontal base, the symmetry, right? This is where we're going to have everything. This is why we did in the center line. So now what we're going to do is we're going to click on this edge here again. We're going to click on this. Let's see if we can do this on this. Let's see if there isn't, then we can just do the center line of the just give me a second, let me see if I can see. I'm pretty sure we can check the, yeah, maybe we can do that. Let's see, Z plane, no, we don't want this. The XZ plane, that's here. Exit plane is not the center. Let's look at this plane. Yeah. Thinking XZ plane might be the center line. Okay, let's go. Let's look back at this. Okay, so for now we don't have a, so to speak, for example, maybe we can make the center line. Center line. Let's see. Okay. Now, this center line that we're going to do is that when y equals 0. So this is at along the pipe's center axis, right? So not the outer wall or the bottom of the pipe. So where is this? This is our, we just have to make a flat edge along the middle, right? This is where our center line is going to be. So what we should do now is, for example, we can just make a line. For example, let's go to our sketching, make a line in the center, and we know this is going from here to here. If always you cannot see it, we can always go back, click on the line, I'm done with the line, and done. Okay, so now we're done with this. We can now go back to our generate. This is now generated, right? Generate. Now we go back to our other thing we were doing with this edge. You can click on this line, and then, so for example, let's see if I can click on that line again. So this horizontal base lies on the pipe center. Okay, so sorry. Okay. Okay, so let's call this the center line here. So the symmetry that over here, let's call this here. Let's call it the symmetry, and the rest is just the what do you call it? What do you call it? The walls, right? The rest of the walls. So now, what we can do now is the same thing we did before. So click on edge. So I click on, and you see here, this is a face, this is filter, faces, bodies, yeah, edges, and then concept and name selection. And we're just gonna call this symmetry. All right, and we are done with this symmetry. Generate, done. Now I just want to check if I can still click on this and do tools. Okay, cancel. So that's fine. Let's delete this. I'm still not sure whether the symmetry should go in the middle or just does the symmetry go in the what do you call it, the edge of the. Pretty sure that's when y equals 0, not the outer wall or the bottom of the pipe. So let me change this to let me change the geometry. Okay, let me see if I can edit selections here and see if I can apply the cancel. Let's delete this. Yes, let's try again. I think it's this one, but I could be wrong, right? So, but we could try and see the modeling situation, and if it doesn't work, it doesn't work. You know what I mean? So, tools, name selection, and that is our symmetry selection, and we can. It's not selecting it. I think that then maybe it's not the, maybe it's just this then. So let's select again. Cancel. It's fine. Delete. Yes. Okay. Let's stick to the other one. This one here. Yeah, it's not selecting. Yeah, okay. This one here. And then we're just going to go tools, name selection, and symmetry. Press OK, and we're done. So generate, and it's done. Now the next part we have over here is, yeah, I think that's fine. That is, oh, it's center line of the whole pipe, so this should be fine. Now, so at least actually we can actually get rid of this if we really wanted to. So this sketch one here, if we go here, sketch, for this line here, we can actually delete it, and then we can generate this again. Yeah, okay. I was stripping, sorry about that. Okay, so now we have our next part where we have to do the walls. Now, the wall is going to be everything that we did not select. So if we were to now go up, back up, and look at what's left, so whatever remaining things we have left, it will be walls. So let's just look at what we have here. 1, 2, so 1, 2, 3, 4, and 5. So now, so if I was to go XY plane, look at, zoom in. Now again, we're just gonna take this, control, click control, 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 control. So all of these should be, so for, so now, okay, give me a second. What do we also, okay. So now, just a keynote here that we do not click on the symmetry, right? Because then there will be no shear stress, there will be no heat flux, and we will not really have anything. So this symmetry line is actually acting like an imaginary mirror on half the model, and on the other half, it will be the same thing. So we just click on this. So these 1, 2, 3, 4, 5, everything. So we have everything else defined, right? And we also had this as the outlet, and this was the symmetry. Now we go back to our tools and name selections, and we call them our wall, right? So now we have everything that we need. So we have wall, and now we just click on enter. So all of this is done. Generate. Now let's check from a side view so we can see. So walls is this, symmetry is that, outlet on this side, inlet secondary on this side, inlet main on this side, and we are done. So control S. All of this is done. Now we can close this. So let's close the geometry. Now what we need to do is we need to just update, and we need to update. So whilst it's updating, sorry about that. Okay, so once it updates, we can go back to our setup, because you can see this is, this is showing progress, it's updating. Once we do this, then it'll be very easier for us to do anything else after this. because now we're going to now start defining our boundary conditions. Once we do the boundary conditions, so our inlet will be a mass flow rate, mass flow inlet, and then we'll have our secondary, which is also a mass flow inlet. Now we'll go back to our setup. So we go back here, and now we double click on boundary. So for example, let's go back. We'll go back here. Let's quit this application. Yeah, that's fine. We're going to refresh it. So let's just close this for now. And we're going to come back to this again. We're going to repeat the steps to see if it made any changes. So okay. So give it a few moments, and then it should work. In general, if you have a more beefier laptop, then this can do it much faster. Alternatively, you can just use Citrix receiver for these ANSYS as well, but it's much slower than what I've seen. So this is why I tried to find another alternative for our students to use. Okay, so let's while this is doing that, so the mesh is updated, the geometry is updated. We're just waiting for this to close. Sometimes it takes a while, so you can see it's not responding. Now it's responding, so it's closed. Now we're just gonna double click this again. Do you want to load the new mesh? Yes, we're going to want to use new mesh. So double precision, yes. Press start, and it's going to start. And hopefully it has loaded the new variables already already inside. Press OK. So once it loads everything, and you can see this. You can see this. It says 2D inlet. All these things are already now in the system. Okay. Okay. Click on OK. Press OK, and now we can go to the same thing again. So let's look at general. The general is fine. Let's look at models. Double click models. So this is energy is on. Standard wall is on. That's fine. Materials. What do we care about? So fluid. We care about water liquid. So this is water liquid. Press close. Now we go to boundary conditions. But now you can see inlet main. It's over here. Inlet main. So display inlet main, inlet secondary. So now what do we need to do? Click on inlet main. Double click this. Now, what do we care about this? We care that what do we want to do with this? We want to go to our magnitude. Where is this? This is the inlet, and we want to change this to, for example, thermal. Give me a second. I have changed to mass flow inlet. So this is a velocity inlet. So can we change this to a? So let's go back here, edit, so parameters. Yeah, create definitions. We want a mass flow rate. Now, what's this mass flow rate? We want to be, so this will be for inlet. So this is just inlet man. So let's call this V1. V1. Okay, this is mass flow rate, and we care about the mass flow rate, and this should be the okay. Let's cancel. Hold on. Not report definitions. Close. Input parameters. Okay. Give me a second, guys. Okay. Oh, sorry. Here we go. Mass flow inlet. This is mass flow inlet. Alright, cool. Here we go. Sorry, I was bugging out. So, mass flow inlet, and we want this to be 1.5. So, 1.5, and that's it. So, 1.5. And normal to the boundary, because this is the boundary, so that's probably that we could change this to direction vector and so forth, but for normal to the boundary, which makes sense, which is in this direction. You can also show this, and then you can show the vector itself, but we're just going to click on normal to boundary, and that's fine. So this inlet made, and we apply it to 1.5 kg per second, and we press close. Now what about the secondary inlet, which is over here? Again, this is a mass flow inlet. He's going to ask us, what is the mass flow inlet? And we're gonna give the mass flow, if you remember, is, so we know it's 1.5 to from the left from this side, and from the bottom it is 1 kilogram. So we're gonna go back. We're gonna put 1 kilogram. Notice the total temperature is starting at 80 degrees. So 80 degrees C should be at, for example, 80 plus 273, so 273, 80. So that's at 3, 7 plus 8, 5, carry the 1, so 353. So this is at 353, press apply, close. Now remember this as well. Let's change this to mass flow inlet, and let's go back to thermal. And this is at 30 degrees C, so this is C as well. Forgot about that. Now 273 add 30, so that's 303. So let's change this to 303 Kelvin. Press apply, press close. All right. Anything else? We know that the outlet, so let's go to the outlet. We want the pressure is pressure outlet. That's good. So let's just click on this again just to see what it looks like. So pressure outlet, yeah, the gauge pressure should be 0, and the backflow temperature should be 30 degrees. Right? Now, we also didn't look at the hydraulic diameter here and the other ones, but we will go back to it in a minute. So we are told that the backflow temperature should be, backflow temperature, if it's mentioned, let's check. Backflow temperature should be 30 degrees, which we said is 303. Right? Okay, anything else? No, normal to the boundary, yeah, that's fine. Thermal, and apply, and close. Let's go back here and see what we said over here. Let's go back here. Now, this have we looked at everything that we could? Let's look at it. So, mass flow rate, direction to the direction vector. If we do this, what happens? Nothing much. It's the boundary, and there's nothing much we can do here. So, absolutely, if we change this as nothing here. So you can always mess around with this just to see what we can get up with. So for example, if we do this, and let's close this. Let's go back here, inlet, secondary. Let's see the same thing here, mass flow inlet, 353, and this is inlet and viscosity ratio. So let's go back, let me just double check this. So mass flow viscosity ratio, yep, 1.5, everything's fine. Okay, now that we're done, let's look at the walls. Now let's look at the walls. So the wall is what? The wall is just type of a wall. So let's look at wall. Let's look at what it looks like. So wall. So it's a stationary wall. It's no slip, and it's standard roughness. It's adiabatic, so stationary. Anything else that we need to know? Nothing. That's it. Yeah. You can change the material name. It doesn't matter, and we can just close this. That's fine. What about the symmetry? The symmetry is just symmetry. So if you oh, sorry, I do apologize. Just look at the symmetry and just apply, and that's close. So this symmetry is symmetry. Okay, everything is done. Now we need to initialize our system. How can we initialize this? You can see it says over here initialize. So click on initialize. So double click on initialize. We want hybrid initialize, and then we click on initialize. So our initialization is done. This is what it says. Now we need to run our calculations. So click on calculations activity, run calculations. So we can click on run calculations. Okay, so what do? We can just do what? We can go our iterations, and we want to make it, let's say for example, let's double click this. We want this autosave, we don't care about this. And let's go over here, let's go to the run calculations icon. And we want, for example, we want 500 iterations, right? So for that, let's check for this one. Let's do 1. This is this number of iterations 0. If you can see here, nothing happened. Now let's change this to, let's say, 500 iterations. So calculate. So you can see, and this is calculating for 500 iterations. Calculation done, and you can look at our scale residuals, and you can see it stopped at 45, right? Okay, so we want our residuals to be below around 0.0001. So around here, this is what we're looking at, the difference between the two iterations. Okay, so we can also change that, use the specified, and okay, so we got that part. Now we also want the temperature contours. So let's go to the results now. So the results, and from the results, let's go to contours. So where are the contours, you may ask? Let me expand everything that we can get. Okay, so plots, we have other things, graphics, we have more things. Now, what do we care about? If you look back at the question was calculate the final temperature of the water coming out of the right side of the longer pipe, estimate atmospheric pressure, verify the problem with calculation, temperature profile, pressure contours, velocity vectors inside the pipe. So we're going to go down. We're going to look at our temperature contours now. So we're going to click on contours. We're going to click on contours. So click on contours. Now, what do we need contours of? We need contours of temperature. So contours of temperature, and we need a filled display. So we're just going to go here, static temperature. So that's fine. Yeah, I think the static temperature should be fine. And we need to have the display to be, let's see, okay, that's fine. None. Should be. Do we need the contour lines? I think that should be fine. Fill display. I think that's fine. Compute, and let's save display. There you go. So you can see the display, the contours. Maybe if I can get the contour lines. Wait, let's compute. Oh, there we go. So this is the mesh with the mesh, and you can see the temperature contour lines as well here, which is pretty cool. And you can get rid of the contour mesh as well. So for example, if you were to compute this, save display, you can see without. Let's look at just the filled values. Let's look at that global range. Let's look at this. Compute, save display, and you can see there's more of a distortion here, purely because what there is, the mesh wasn't as clear. If you look at the mesh as well, it's fine. Compute, save display, and you can look here. So these parts here are our biggest nodes, so that's why you can see there's a more distortion over there. So this is our, so let's put everything so it just looks nicer. Let's compute, save display, and here we go. This is our temperature contour map. So that's one task done. Now we want to change this to pressure contour. So we're going to go for pressure contour, and we're going to press save display, and you can see over here we're going to compute this. Let's get rid of the mesh and see what it looks like, and here we go. So what are we saying? We're saying that there's a lot less pressure here, right, than there is over here. There's negative pressure here, and there's positive pressure all around this inlet. And you can see, for example, if I was to move it here, so most of the pressure that's being built up here is around here. Negative pressure is here. Okay, which makes sense. This is the where the most of the water is hit from this side and this side, so they collide over here. And you can see there's some turbulent behavior here and here, which makes sense. Okay, now our velocity vectors. So what do we do now? We need vectors. You can see there's a vector icon there. I'm going to close this. We're going to go to vectors. We're going to double click vectors. So results vectors. And then from the vectors, we want to click what? We want to click on velocity. Velocity is there. And let's see if we can do compute, save display, and here we go. This is these are the small. You can see the velocities here. Pretty cool, pretty niche stuff here. Pretty nice. And the magnitude is just the, for example, let's zoom in here. So these are all green. So for example, the velocity here is, so there's more velocity here than there is, for example, here or here, which makes sense, right? There's more turbulent behavior over here as opposed to the rest of the entire thing. Now let's just click on draw mesh as well, so it might make us appreciate what's going on here. So we can see the mesh, and we can see with the mesh what we can see over here as well. Okay, so also we can change the mesh and how we draw the mesh as well, so that's fine as well. We can also increase this scale. So let's scale this to maybe, let's say 5. So we can save display, and you can see they're now more larger, right? So this is just for our convenience, just to see what's happening with the velocity, right? You can see that there is some lots of turbulent behavior around here, and there's some less turbulent behavior over here, and after that cools down, and then it's just fast velocity here. It's mostly laminar, and yeah, okay. So we did the velocity vectors. Now the last part of the question, or the first part rather, is the final temperature. We need to find the average outlet temperature. So we did the temperature profile, we did the pressure controllers, we did the velocity vectors inside the pipe. Now we need to do the final temperature. So now let's go back to our over here. Now, how do we do this? We just go to reports over here, and we care about what the surface integrals, right? So surface integrals, how can we get this data? So we can click on surfaces. So let's get rid of this surface. After grading surface, we need to go to surface type. Let's see, outlet. So click on this outlet, and let's see, not this. Let's see, where can we find the where can we find the average, or let's say the final outlet temperature? Okay, report is vast. Okay, let's check here. Is it here? Oh, we go. Sorry, yeah, it's here. Surface integrals. So we double click surface integrals. All right, area. So we have the area, and this we want the area. We want the weighted average, and then for there, what do we want? We want the static temperature. We want the static temperature, and we want it of what? For example, we want it of the outlet. So we compute, and it tells you this is around 324.55318. Now we can use our calculator just to double check. So fx. So this is 324.5332. Take away 273.15, and we get 51 degrees. We get 51 degrees. Okay, so that's that. Now, how can we verify this T out via hand? Let's try to see if we can verify this T out. So let's go back to our thing here. Okay, so we know the T out. So let's see if I can do it via this exactly. We know T out. So let's say TO should be what? It should be our mass flow rate 1.5. So I'll write, this is a fraction, so we're dividing by another fraction. So it's our as mass flow rate that goes in, so 1.5, right, multiplied by our 30, right, 30 plus this is our temperature, by the way, plus our, again, one, this is 1 times 80. This is the mass flow rate going inwards. Okay, divided by the 1.5 plus 1. Let's see what this gives us. Let's go back to our here. All right, let's see. So let's go here. So let's do 1.5 times 30 plus 1 times 80 over 1.5 plus 1. And we get 50. So we should get around this range. So this is around 50. So we have approximately, it's pretty accurate, our ANSYS results. Okay, so this is done, and we are done with the video, and I'll see you guys in the next one. So for now, you can Control S if you wanted. I think we can get the report outline if I'm not wrong. Let's see. Yeah, okay, let's see if we can get, let's see if we generate this. Let's see what happens. So let's generate this just to see what we can get. And it's generating, so it might take some time. But yeah, in the meantime, this is the ANSYS tutorial. I hope you found that helpful. There was a couple of hiccups. I hope that it still helped you guys, and I'll be looking forward to helping you even more. Okay. Now, whilst this does this, I can see it might take some time. So I might just stop this, and if any results happen, I can just forward it on my YouTube link, or maybe some Google Drive, because I'm not sure if we can generate it directly, because it still says, you can see it says not responding, so I'm not sure. Whether this will go on or not, I'm really not sure. But the main things here, over here, once you're here, you need to make sure you save the project. Always save it. So we're gonna save this, and when you save it, you're gonna have two files. So I'm going to go here, go on desktop. I'm gonna make a new folder. I'm just going to write this is my ANSYS tutorials, and I'm gonna go here. And I'm gonna write this is a lab to Asan Khan. I'm gonna save this. Whilst this is saving, and you can see it's almost generating the files. Let's see what it looks like, because I'm also interested on what it might generate. This is the first time I'm generating it. Okay, so once you've saved it, always save your project at the end, and make sure that whenever you save the file, whenever you give the file to someone, you have the backup files and the project file, so they can always, it always works. Alright, let's see. So it's managing templates on all this. Let's see, it's almost done. Just bear with me. Alright. Okay, almost done. 1991 clear. Just know that ANSYS is a very sophisticated software. You can get so many things from this, so you can always get lots and lots of different softwares here. Let's look at this. What's this here? So image load. Okay, so mesh size. Okay, cool, nice, interesting. Plots, contours. Let's see if we can export this PDF. Let's just see what it looks like, and let's see if we can save this on the desktop as tutorial. And let's press OK. I think whilst it saves, we can double check it out. So desktop, ANSYS tutorials, and I think it's saving. It's saving. So maybe it's here. Not sure. Maybe not. Let's check. Is it already saved, or I'm not sure. Okay. There we go. Let's take a look at this then. So this is the profile. I'm guessing it didn't show the proper imaging. I'm not sure why.